perfect follow-on. After the last presentation, I think you'll have, if you're new to the HBase world, there's always a lot to learn. And so great setup there. I want to, well, I guess first introduce myself. I'm Clay Benziger with Bloomberg. And we run quite a bit of HBase, at least for our business. And I'm part of our Hadoop infrastructure team. So we're responsible for HBase, HDFS, core Hadoop as far as Yarn and all that as well. But HBase has really been a huge driver for us and growing the team as well. So some of you may not know about Bloomberg. Just to kind of give some background, this is our iconic Bloomberg terminal. And we started in '81. We've got 325,000 subscribers in over 170 countries. We're a large company. We've got 19,000 folks, 5,000 software engineers, do a lot of machine learning. That group's grown a ton. We've got more news reporters than the New York Times, Washington Post, and Chicago Tribune combined, I believe, and 125,000 news content sources, more than 1.5 million news stories every day that we acquire and publish. And so one of the fun parts about this is the amount of data that we get. You know, the financial industry is a key driver for us, so we get over 100 billion tick messages, basically an offer to exchange an asset every day, and the peaks can be incredibly bursty. You know, if you think of everyone at a Super Bowl or something, that's a lot of users, you know, all saying, hey, you know, I want to know what the betting score is, you know, as I watch the game or what have you. But for us, with the opening of a stock market, well, race is off, so we get a ton of very bursty traffic. With that, we do a lot of, therefore, kind of what we think is at least intermediate HBase operations. Hadn't seen anyone present at HBase Con kind of a good metrics deep dive of the JMX metrics available on HBase. And so I really want to talk about monitoring HBase and kind of what some of the JMX metrics available are. Whether you're an infrastructure operator and it's your job to run HBase, as mine is, for application teams, or if you're an application developer who has somebody running HBase for you, and you need to know what's going on in my HBase. You know, what is my data store doing? It's great to know kind of the key metrics. That way you can have your operational view. And of course, all of us, you know, hey, I've got a problem. Where do I look? I want to talk about some of the tools that we actually at Bloomberg have started using that we found as a really powerful driver for us. We have many HBase clusters. One of the challenges is, how do I find that HBase cluster? And particularly with different versions of HBase, different versions of Phoenix in our case as well, how do I talk to my cluster? And similarly, you know, just kind of what code is running on a cluster, or, you know, how many regions I've got. Oh my God, I got so many regions, and I need to affect things. So I want to talk about some maintenance operations that works well for us. With that, you know, kind of, is this thing on? With HBase, one of the interesting challenges is HBase up? It's a distributed data store. One of the challenges with that is, how do you say for sure that your HBase is actually up? All of your data is available. You know, all the region servers are online. And that's kind of a hard question to answer. So the first part is just stopping and saying, hey, you know, how many region servers do I have that are currently checked in? And this isn't a trivial JMX metric, the number of region servers. It's published by your HBase master. So your HBase master can tell you this is the size of your cluster. Number of dead region servers is a really useful thing. You might be looking at the number of region servers and saying, oh, great, everything looks great. Oh, except for I've got 2 dead region servers. What happened? This can be really useful if you use automated configuration management. At Bloomberg, we use Chef for our configuration management, not Embari, not Cloud Era Manager. And one of the challenges is if you get in a hysteresis situation where you're bouncing region servers left and right, all of a sudden you realize, oh, shoot, the master thinks a number of region servers have died. We actually might be restarting region servers faster than we realize, and it looks like everything's online. Regions in transition are another great example. So great, I've got a region, you know, all my region servers checked in, but I can't query any of my data. Why is none of my data available? Regions in transition, when HBase is either splitting a region or moving regions between region servers, should there be some failure, that region can get stuck in transition. So there's some very key metrics here. You've got the oldest region in transition. Maybe you've got an HDFS file that got corrupted. You know, all 3 hard disks that were storing that replica went bad on you. Well, that region will never be able to be assigned to a region server. We can't open it because we can't read the data. So that region is stuck permanently in transition, and that JMX metric will be increasing throughout time until you eventually delete that region. Similarly, you can set a threshold. So maybe you say, hey, you know what? We can tolerate regions being in transition for up to a minute. You know, we're running on slow hard disks, and we're doing a lot of ingest, so we got regions that get stuck in transition. But you want to alarm over that 1 minute threshold. This is another JMX metric that's super useful to look at. And then just in general, you want to look at, how things are doing, as quickly as you can to the lowest granularity, and that's your region in transition count. Again, all three of these are published by your HBase master because that's where the assignment manager in HBase lives. That's what actually drives where those shards should get placed on the cluster. Some similar stuff. Maybe you go, well, hey, I don't have any regions stuck in transition, but reads are still just really, I'm having severe problems. Maybe you've got some network issues or some other issue that you weren't aware of that's affecting HDFS. And when that starts to happen, you'll see metrics from your region servers in this case, or even your HBase master, which also requires HDFS, increasing. And you've got your FS read time and your FSP read time. The difference being FS read time is your sequential read time. If you've got hard disks, you can read sequentially relatively reasonably. But now, all of a sudden, maybe you've got a lot of seeks, maybe different workloads running on those hard disks with HBase, and that's where you'll see your actual seek read times start creeping up, where your sequential read times may not actually be as bad. Or vice versa, depending on if you're using SSDs and all of a sudden start having read and write holes developing. Same thing with FS write time. If you're running on SSDs, that first day you deploy the cluster, you're like, wow, yeah, this is great. 3 years later, as you start ending up with write holes, and now that SSD has to find parts of itself that isn't damaged, well, you're like, man, I just can't write to this HBase cluster. These are metrics that we've seen are incredibly valuable. And again, you can see these from region servers. One of the ones that I love the best, and we run some co-processors and some custom filters at Bloomberg that sometimes can cause interesting, unexpected issues with HBase, aside from just bugs in general, is exceptions. And again, you can see this on both HBase masters and HBase regions, which is what exceptions am I currently experiencing? And it doesn't give you a great granularity, but you can at least see that, oh, I'm getting exceptions. And you might have a client who says, every time I query, I don't get any data back. And all of a sudden you see this metric. Oh yeah, every time you query, I see this metric increase. Again, it's one of those kind of just default checkalls that's useful.
Are you looking at the exception counts in like the JVM metrics, or are you looking at the logs?
So everything I'm presenting, Rob's question is, is this out of the logs or the JVM metrics? And everything I'm presenting is actually JMX metrics. So yeah, and a good point. Are these JVM metrics or are these HBase metrics? And that one's a JVM metric. For the most part, I'm trying to focus on HBase metrics, though I think, as a presentation before me did a great job kind of covering a lot of the key stuff like garbage collection and things like that. But yeah, this is mainly HBase JMX metrics right now. So now that's great. We've got at least a reasonable plausibility that we have a cluster and it is online. It's got data loaded into it. But now what's going on here? And this is one of the places where application teams really tend to have a hard time sometimes when they start getting distributed clients. They've got this great distributed data store. And they say, well, how are my queries affecting the cluster? Or what do my queries look like? It couldn't be me that's doing all of these queries. So you got both read and write metrics there. Compactions, a key operational issue with HBase. Hey, I'm doing all this ingest. It's working great. I like my HBase infrastructure team. They're absorbing my data, and all of a sudden things stop. What's going on? And again, compactions are a key part there. Splits, same thing. If I'm, that's great. I'm absorbing lots of data. Well, now all my HBase regions, all my shards are actually growing large enough that I need to split them. I need to have more shards. And again, that can be a write availability issue. So we'll get to that. And replication. Replication in HBase is incredibly configurable, but the reason, usually at least, folks use replication is because one side might go down. And when that happens, how do you check your source cluster that's saying, hey, I'll send data as soon as it comes back to make sure it doesn't have issues, and then just, oh my, all of those catch-alls that have thrown issues up. And so, of course, probably most folks who have been running HBase for a while, you've got your dashboards and everything's great. You've just got so many graphs. You're like, so many graphs, so many questions. Where do I start? Well, with that, let's talk about queries. So with queries, you've got kind of some key parts, even just for reads. Are you doing gets or scans? HBase is great at point lookups. You've got your block cache and your bucket cache that do great for point gets. But then you also have scans. HBase is unique that you can very efficiently do bounded row key scans or even full table scans. And that's fantastic that you've got those, but they're very different patterns. And so you have to really understand that. One of the things you often see is when you start running mixed workloads on HBase, maybe multi-tenant HBase, you might have a lot of folks who are doing get lookups and everything was fantastic. Now you introduce scans and everyone says, oh my God, things have really gone to heck. I don't know what's going on. And there's tunings in HBase that you can set, your call queue tunings. And it's possible for you to actually set percentages of your queues so that you can say, hey, you know what? We're going to prioritize gets this percentage of the cluster and scans that percentage of the cluster. And this is a really useful series of metrics. Similarly, reads, you've got size of your reads. So now, this isn't size of the data, but the actual return data as well as the requested data. One of the interesting parts that we've seen is as folks start growing their applications and they say, yes, Clay, I will join your infrastructure, I'll be one of your tenants, and I'm going to just write 4 kilobytes of data really normally. Every once in a while, there might be an outlier. Okay, cool. Is that outlier? Yeah, no. 99.99999% of the time, that outlier is really close to 4 kilobytes. Every once in a while, it's not. And if you're not watching the size, it can be a big problem for you because now you all of a sudden start having big bubbles going through HBase. So now, yes, I'm reading 4 kilobyte records, except for that 10 megabyte record that I wrote. And so this is a really useful part, again, for an HBase operator to look at the maximum size of your responses. Similarly, for requests, if you've got very large multi-get requests or multi-put requests, and then just hotspotting in general. So one of the really beautiful things about all of these metrics is the granularity of them. But you can actually get very detailed to understand, is a particular region getting really hot? Or is a particular region server really hot? And so again, very key part, and we'll discuss that more here in a minute. And then just other JMX metrics to look at is cache hits, whether you're actually using that block cache. It's great that maybe you have a 100 gigabyte off-heap cache, but if your cache hit rate's really low, then clearly you're not making the best use of it. The number of store files, and this is actually something that's been lighting me up today. It's one of our tenants has way too many store files. HBase is fantastic in that it shards underneath the hood, and you get all of your regions. And then each of those regions is made up of individual store files that get written to HDFS. Now, HBase is a log-structured merge tree. It takes all of your writes, and it just writes new logs out. Eventually, it has to compact them and make them back into a single store file. If you're writing a lot, or you're disabling compactions and manually compacting when you feel it's a good time to do this, you can end up with tens or even hundreds of store files potentially. And that means every request has to look through, if maybe it's a key that doesn't actually exist in your HBase, and it actually has to look through each of those store files and say, hey, is that store file potentially contain that key? And so it can really degrade your performance. So again, you can look at on a per region level metric, or kind of how many store files are making things up. And then also you can look at hardware issues. Sometimes it reads. You've got your queue call time. So how long did you wait in the queue for HBase to service your read versus the processing call time? Now, if you've got very complex coprocessors, your process call time might be somewhat fuzzy from that. But most people are just using vanilla HBase with Phoenix. It's very interesting if you start to see your process call time grow and your queue call time not. Because one of the things we have seen particularly is that on flaky hardware, where maybe a CPU is running slow, a hard disk is running slow, not enough to be seen through other metrics, we'll watch that process call time just start to creep up, even though it's the same workload that's been running on that region server for the last quite some time. So these are some of the useful metrics that we've seen for those reads. Similarly for mutations. So, that's great. We got reads, except for I need to get my data into HBase. How do I do that? Well, the mem store is a very key part. So I think a number of presentations today have mentioned the mem store. It's on your write path as you actually write data into HBase. Well, you can look at per region how much your mem store is affected. So maybe you've got a region server, again, multi-tenant, you've got different applications writing in, and you start noticing things like, hey, I've got a lot of small store file sizes. And why is that? I'm flushing a lot. As Dice mentioned earlier in his presentation, you can see this in the logs, you're flushing a lot. Well, one of the questions can be, well, what's your mem store impact by each region? And you can find if you have a noisy neighbor on that region server, somebody who's just outsized from the other tenants. But now, I keep mentioning region metrics versus region server metrics, and the granularity for this is really key and something that I think a lot of folks aren't quite aware of. One of the things we find in a multi-tenant shop is that the user metrics are fantastic. And HBase reports all of these read and mutation metrics per user. So that, I come in and they can say, hey, Clay's an administrator. He does very few reads and writes. But we can see that application A might be very write heavy. We can see application B is very read heavy. And should an application start to change, it's much more obvious to look at their user metrics than per region metrics, per server metrics, because that's kind of lost in the noise of the per server metrics, but it's very useful to see for user metrics. Similarly, you can look at each region in HBase, and this is very key for trying to diagnose a lot of issues that we see, at least, where it might be one application is having just parts of their data that are returning slow. And so we really have to investigate the region that's responsible for that row key or those series of row keys. And so again, very useful. Only slight challenge with region metrics is they will blow up your metric subsystem. One one region server can host, best practices, 300 regions. Certainly people will push that into the thousands in some cases. And then you might have 100 nodes. So now we're talking millions of metrics just for that one type of, per region read metrics or per region write metrics. And I think the granularity of all of these is quite a bit. I believe there's about 90 metrics per user, per region server. Regions, I believe, is 150, if I recall right. I think tables is 240 metrics. These start to get quite big. So when you're planning your metric subsystem, if you are trying to look at, hey, you know what, we're going to install a 50-node HBase cluster, how do we do this? The scaling starts to become kind of a concern. And sorry, I don't have the exact numbers there in my speaker notes, but they'll be uploaded. Similarly, the cluster-wide impact is very useful. So sometimes trying to actually view this, hey, I've got 50 region servers. I want to see what the impact of this particular table is, how many reads they're getting across the cluster. Now you need a metric system that can sum it all up. So I can say, hey, take every region server's table metrics for reads and sum that up. So it's an interesting use case that a lot of metrics groups I've dealt with have said, wait, you want us to do, that's an analytical process. Yes, I need analytical metrics for HBase. So with that, we've got kind of compactions as well. HBase has two different types of compactions. Your major compactions, where you actually can delete data, versus minor, let's just at least keep bundling these up into files, cleaning up the direct flushes from the mem store. Again, very useful metrics to look at, both from a CPU usage standpoint, as well as from the fact that these queues can sometimes be driven by things that you may not expect, such as bulk loading, where you might now all of a sudden have too many store files, and HBase's heuristics will kick in, even if you have compactions disabled. The queues here, a very key thing is to double check, like say, that your compaction queues aren't growing unbounded, or your compaction queues aren't just stably staying very high. In the image here, we actually see some compaction queues for a mock cluster, but we can see that the compaction queues for, it's about 4 machines, just bobble along in the thousands. They just aren't really making any progress here. We can see one dropped very sharply, though. And in this case, these are machines that have faulty I/O subsystems. So because of large caches, everything looks largely fine. Their HDFS read times aren't terrible, but that's because they're going to network devices that aren't local. So we don't really see anything obvious here. This OS metrics, the machine's not really doing enough for us to see slow disk times, but it actually isn't making very good progress. The machine that just dropped was restarted, clearing up those I/O issues. There's about 30 more machines hiding in the noise. So a key thing to double check here is, is compaction working across my cluster well, or do I have some slow region servers for some reason? And again, we can look at this per region. Maybe a particular tenant just keeps compacting one region really hard. Perhaps there's a particular table that's doing a lot of ingest, and so they're causing a lot of compaction, but other users can't get their compactions done timely because of that. And so you can look at the per region server metrics as well. So, let's talk about splits. One of the biggest things that we have, SLAs are incredibly key for us at Bloomberg. We've talked at past HBase cons about needing sub 10 millisecond types of SLAs. But one of the biggest challenges now too is write SLAs. We want to make sure that we can take a write, and we can take a write in a bounded amount of time. One of the problems is when HBase is doing a split, it's a very complex operation. And when you are doing a split, you're taking one region and making it 2, which means that you may lose that concept that I have one region server responsible for all that data. HBase's way to deal with that is to make that region unwritable. So it can still be read on that region server that was hosting it, but it's unwritable. And it's a rather complex state diagram, as you can see from the HBase reference guide here. So one of the key metrics here is to looking at the split time max. And you can look at the split time max both for your per table and region server. One other new thing, we run HBase stable. We're still on like 1.2 for the most part. But one of the challenges is in the normalizer too could potentially be coordinating splits. So you want to look on your HBase master for normalizer plans as well. Another key part is maybe you got a ton of writes, you're doing great, but your splits never really seem to complete. And it seems like you're always just having regions growing far too large for your comfort. One of the other key things is to look at split success count. You may be too busy to split. And so if a compaction or something else comes along, then it can invalidate that split. One of the very fun things that I remember a tenant coming to me about was a split storm. They didn't expect splits. They had perfectly uniformly distributed data. I mean, they were really good at designing their hash key. Unfortunately, all of a sudden they went from like 2,000 to 4,000 regions and completely blew themselves up. Well, one of the things to think about if you are using a particular split policy is what split policy you're using. There's about 6 of them, and they can have things like constant size. So every region, if you're perfectly uniformly distributed, ticks over roughly at the same time over that byte range, and HBase says, oh, it's time to split you. Okay, great. So be aware of impending changes in your data structure that way. So again, you can kind of watch this if you haven't hit it before. If you think somebody hit it, you've got to forensically go back and look. And if you don't have logs handy, you can look at split time number of ops from a region server, and you can, or excuse me, split time number of ops for a table, or you can look at the region counts for a region server and just say, hey, wait, all my region servers seem to have doubled regions. Yeah, this makes good sense. I believe you also have region count from tables, so very useful metrics there. Next thing is replication, and as was mentioned in the last presentation, walls can back up on HDFS. You've got one cluster that's sending write-ahead logs, that other cluster is absorbing it great, and all of a sudden somebody cuts your link. You go, that's great, that cluster will be turned on today or later today, maybe tomorrow morning. Day goes by, no, there's still problems. Another day goes by, oh, no, there's still problems. All of a sudden you go, wow, my HDFS is almost full, but you know, it shouldn't be that bad. I mean, we're compacting data out, the TTLs one day, whatever. Well, all those walls are backing up. And so size of log queue is a very useful replication metric that you can find in JMX from your region servers to be able to understand how much do I have that I need to get through this buffer. And similarly, another very useful thing if you're trying to start to kind of bound SLAs on replication is looking at the age of the last shipped operation and the age of the last applied operation, making sure those are relatively in sync for your replication peers. So these are region server granularity, but again, talking about the computability of metrics necessary for HBase, now you actually want the difference between 2 clusters. So if your metrics infrastructure doesn't let you look at multiple clusters at the same time, this starts to get really difficult because now you need to have some way to do that. So, oh my! So Java garbage collection is something that there's way more presentations than we could talk about, but Java garbage collection will certainly stop your world. Numbers of regions per region server, and this is an interesting one that you'll sometimes see. Maybe you're running heterogeneous HBase clusters, and all of a sudden you go, hey, that's great, all my region servers have 300 metrics, except for this one that has 3,000. Why is that? And sometimes it can be very difficult to start to diagnose, why is my region skew between region servers so asymmetric and unexpected? HBase has a balancer that tries to balance regions across all of your region servers called the stochastic load balancer. It's a cost-based load balancer. It generates a cost of moving those regions, a cost of where it would place those regions, and that cost function sometimes can interact in unexpected ways. Data locality is a used metric, load on the region server is a metric, size of the region, if I recall right, is a metric. So all of these are very useful to look at. You can look at that with the balancer cost metrics in your HBase master. And coprocessors. So again, coprocessors can do whatever they want on a region server, potentially tying up your region handlers. So now, I can't do any writes or reads because HBase is just queuing me up. Well, what's going on? If you write coprocessors, it's very useful that you use the metric subsystem so you can actually say what's going on, and then you get JMX metrics from your coprocessors. The Phoenix indexer is a good example of that. Let's see, so yeah, one of the very cool tools that we've got many HBase clusters at Bloomberg, and one of the questions is, how do I access my HBase cluster? I can use REST, I can use Thrift. These are great ways to do it. They require gateways that then translate either the REST API or the Thrift API into the Java protobuf API to talk to HBase. Or you could use a native Java client. That tends to be what we focus on because of the low latency of it, and it's just kind of the most up-to-date, if you will, of all the features of HBase. But it requires a number of configuration parameters that, as an infrastructure operator, since I know exactly how that cluster works, really easy. When I have tens or hundreds of tenant application teams, it starts to get a little fuzzier. And so that can be requiring a zookeeper quorum, all the hosts and ports and whatnot for that zookeeper quorum. Needing shared configuration parameters. So this could be things like Phoenix namespacing enabled or not. I don't want to have server-specific parameters. So, I want to make sure that I don't have a Hbase principle that has a particular server's name. It should, just map depending on the server. And, simply, I would like to provide a single handle just so I can make people onboard my infrastructure faster. I want them to be able to just say, hey, I'm talking to cluster A. Please give me cluster A. And one pattern that we see a lot is people just copy HBase site.xml. And unfortunately, that means that they get all sorts of things they don't need or that can really break them. So we wrote a connection library, and basically it uses a very cool feature of HBase, the /conf endpoint. And that /conf endpoint is not Kerberos authenticated or Spinigo authenticated, even on a Kerberized cluster. This could be good or bad, depending on your security posture and what exactly you've got in your configuration. But usually configurations are pretty benign. They list various daemon attributes, though, and some key things that they do are kind of those default HBase principles. Your master has to have a default one for your region servers. Your region server has to have a default principle for your master. These types of things are very helpful. Your Hadoop authentication type, is this a Kerberized cluster? The Zookeeper quorum for that cluster, as well as the root znode, if you happen to be running multiple HBases on a single cluster. Your HDFS service ID, name node, and principal. So that way, I can actually write to HDFS if I'm doing a bulk load or something like that. Any Phoenix configurations will also be there. If the region server or the master needs to have those Phoenix configurations, they'll be listed in its configuration. But some of those things that can trip up a tenant if they were to copy HBase site might be like LDAP group mapping password files that they don't need and they wouldn't be able to read anyways. Specific Kerberos principles and key tab names. And service timeouts. Your timeout as an HBase client on a region server is probably very different than what you want on a low latency application. So we wrote a library that actually uses that conf endpoint. All the daemons offer it. It's not Spinigo authenticated, which means that it's very easy to put behind a load balancer. The service itself doesn't need to know what host names it might be resolvable as. If you've tried to configure a Kerberos service so that it can be accessed by multiple host names, you'll know it's not a trivial thing to do, and it can be quite painful. This, luckily, is about as simple as it can get, but at least those key Java client attributes that you really need, the Zookeeper quorum information, the default principles, the service ID, Phoenix configuration, it still does have all that stuff you don't want clients to have, most of those miscellaneous configurations, and it's not always those optimal client tunings. So the way we came over that is with our process flow for how this library works. It takes an API so that you would just give it a cluster name. Well, that's great, but we still have to do service discovery somehow. And one of the trivial ways to do that is just through virtual IP or DNS, which just says, hey, that's a cluster name, that fully qualified host, great, wave our hands there, and it's very easy. But then we get /conf from any of the daemons. And we do some health checking, so we make sure that that daemon is plausibly up and don't just send them to a dead end. But one other really nice thing is that we can provide a static file. And so that static file is really trivial. It's just a blacklist of options that we don't want it to use. Basically anything cluster-specific or server-specific that we need to blank out. And then it returns two really useful things. It returns either a configuration object, so they can just put in their Maven POM file or the SBT configuration, hey, I depend on this library, or they can just generate an HBase site with it. So this way, it's a really nice, easy way to go. Now I want to talk about some maintenance fun. And my apologies, I'm kind of speeding up. My laptop's about to die, apparently, so not sure where there's a power outlet over here. But HBase Shell, it's kind of a multi-tool if you're an HBase administrator. I've got my power bricks, or if you'd be able to help me with that. It's a multi-tool for HBase maintenance. So you can actually say, thank you. Basically, like, what regions on this server have coprocessors loaded? If you do a lot of custom coprocessor work, you'll find that it's very difficult to have coprocessors loaded when they're undergoing development and have a stable HBase cluster. And this can be difficult in kind of a general purpose HBase cluster because now you've got these different coprocessors throwing different issues. You go, this region server crashed. Why did it crash? Or this region server is just behaving funny. If it crashed, you can't ask its JMX metrics anymore, or can't ask it questions from HBase Shell. But using HBase Shell, as long as it's alive, you can query the cluster and say, what coprocessors are loaded on these regions? Similarly, you can update cluster state. And this is one that kind of new administrators on the team always say, Clay, so the cluster I was administrating has 1,000 regions stuck in transition. Do I have to type all of those somewhere and click a button to do a sign? And usually the poor intern looks very worried or something. And no, you don't have to do that. So I want to just walk through for folks who aren't used to HBase Shell and kind of haven't thought about how it can be a useful tool. So let's walk through what it looks like to enumerate all the coprocessors through HBase Shell. HBase Shell is a Java API client, but it's also a JRuby implementation. So you actually have a very nice lightweight programming language with a REPL. So you can just type as you want with it. So this file here, coprocessors.rb, uses the JRuby syntax for requiring a set operator. But otherwise, then all of a sudden we tell it, hey, no, but include Java as well. Now we can start doing Java-isms. So I can include the HBase configuration, the htable object, table name, an exception, because I'll throw it, table not found. And then I can actually write functions. Again, in Ruby syntax, so it's very nice and compact. Coprocessor is the name of my function, so creative. And I need a configuration. So now we kind of see the melding of the two here. It's conf equals HBase configuration.new. HBase configuration being that org Apache Hadoop HBase configuration. So I can very quickly, as an administrator, if somebody says, hey, I need to get help here, I need to understand what's going on, or I need to fix something before things get worse, I can write code to make that happen. So here, we've got coprocessors, htable objects, and JRuby all melding. So I can actually use the HBase Shell's Ruby API for, like I said, sets, as well as loop constructs, which are really nice and easy. So I can say, hey, the coprocessors will be a set, a JRuby set object, and I want for all of the tables that I have read through. My apologies, slides are missing. Anyways, for all of these tables, I want to loop through those tables, and I want to create a new htable object. And I want to get the table descriptor, and I want to then be able to say, hey, if that table descriptor is not there, rescue, just as I would in Java with a try-catch block. Here it's a Ruby begin, rescue, and end block. I just simply print that exception, because in this case it's not a strong failure. And then I want to say, hey, get the coprocessors off that htable descriptor. I'll convert it to a Ruby array now, because that's just much easier to work with. And then for each of those htable descriptor coprocessors, I'll add it back to that set object. So now at the end, I have a JRuby set with a list of all of my coprocessors. And when it's run, oh, right, tables were passed in, sorry. So now when it's run, I can actually load a file with all the tables that I want to enumerate over, again, using JRuby's syntax, which is very nice and compact, and say, hey, just start with that coprocessors.rb. It's now loaded into my HBase Shell REPL, so I've got that coprocessor function we defined. And I can say, hey, the variable t here will just be simply an array from opening a file called tables and being able to walk through that and then just read each line. So within about 4 lines, I've got a nice array of tables, and I can pass it to that coprocessors function. I can now walk through that set that the coprocessors function returned to me, and I can actually print out just the last part of the string. In this case, it returns you a Java-style class string. So it would be org.apache.hbase.indexer.indexer or something akin to that, and org.apache.phoenix. Some other stuff grouped to aggregate region observer. And on this particular cluster, you can see GeoMesa was loaded. So it's very possible to be able to actually do very quick operations rather than having to write a Java program, compile it, ship it to the cluster, and all of that. It's very nice for administrative functions. Another fun issue, assigning regions. So you got those regions stuck in transition. Maybe you had an HDFS outage or something, and these 8 regions got stuck permanently in transition, permanently in air quotes here, because now you've fixed whatever problem was hanging them up, and you need to tell HBase to assign them all. So again, I could have that region listing from various means. I can actually get it through HBase Shell as well. But here I can easily open a file, iterate through each line if each line is a region ID, and assign it. One of the nice things is, we'll see here on line 4, assign is an HBase Shellism that HBase Shell provides you a nice easy operator for. So I can just give it a region ID, and it will now assign the region. So with that, I'm sure there are hopefully questions or ideas that some folks might have.
So you showed like the Ruby API.
Yeah. So the question is, we've got HBase Shell, which has a Ruby API. Are there any other APIs, language API bindings for HBase Shell? And HBase Shell is just a JRuby program. So you could certainly write this, maybe using the HBase REST API to be Python or otherwise for what the HBase REST server is able to provide. But HBase Shell is only JRuby. So. Any other questions? Actually, one fun thing, if you've noticed me on my laptop so far, a tenant asked me today and said, hey, I've got an example on my public GitHub of how to use Uzi for major compactions, but it's just kind of a trivial one. It just compacts the whole table flat. and a tenant reached out to me and said, hey, I need to do a rolling compaction of my table. I don't want to compact the whole table at once and blow up my compaction queues on my cluster. I need to do a rolling compaction of each region, and ideally by some weighting. You know, some regions are much more important. They might have more store files to compact. Can you help me with that? And you know, I figured, boy, I can't walk them through doing this while I'm at the conference. I'll just send him an HBase Shell file and tell him, here, run this. And it's got like 3 functions that he can run to do a rolling compaction of his table. So it's a really nice, like I say, tool for that. So, yeah, cool. Well, thank you guys. Thank you, everyone.